Okay, good evening, everybody. Thank you so much for joining us here today at the Geological Society. My name is Natasha Stephen. I'm the Director of Science and Engagement here at the Society. It's wonderful to welcome all of you who are here in the room and all of you that are online as well. So thank you very much for coming along. It's going to be a very interactive talk this evening, I understand. So I hope those of you that are at home have got pens and paper at the ready. If not, you've got a couple of minutes now to go and find something. And those of you in the room, if you didn't pick some up on the way in, there is paper and pencils at the back for you as well. So do please grab something and join in. Before we get started, for those of you in the room, just a little bit of housekeeping for you. We're not expecting a fire drill this evening. So if you do hear an alarm, please treat it as a real event. Don't panic, but follow members of staff outside. We've got a number of fire exits in the room. There's one here at the front behind the curtain and 3 at the back. And there'll be a number of staff who will lead you outside. And we have a muster point in the courtyard in between all of the societies in front of the Royal Astronomical Society. So do just follow us and we'll get everybody back inside as soon as it's safe to do so. So without further ado, I'd like to introduce our speaker for today's public lecture. We do our public lectures every month throughout the year, and it's my pleasure to invite a colleague and friend today, Matthew Genge, who's here from Imperial College, a reader in Earth and Planetary Sciences. Matt has a multitude of skills and is known very much for teaching, for research, but also more recently for his artistic skills in the scientific field. He actually published a book a couple of years ago on the art of geology. So we're really looking forward to a bit of a guided tour as to how to do this, hence the interactive element this evening. So we'll do a Q&A at the end. Those of you that are online, if you do have any questions, please use the Q&A function and we'll read them out for the benefit of everybody in the room at the end. And those of you in the room, just put your hand up, we'll get a mic to you and we'll do questions that way so people online can hear you as well. So without further ado, please everybody welcome Matt to the stage.
Hello. So this is going to be a bit different for me and for you, hopefully. So I'm used to standing up here talking about my planetary science research, but today I'm going to be telling you about the art of geology, and in particular about how we as geologists, how we use drawing and art as a fundamental part of our discipline. And I'm going to make the suggestion that geology is the most artful of all the sciences, that we make the most use of art. And this will be also very much a practical lecture. So I'm going to be discussing techniques and methods by which you yourselves can improve your drawing and your use of art in your science or pastime, or however you approach geology. And I think I'm going to start with the uncomfortable truth. The uncomfortable truth being that geology is about colouring in. Now, I expect everybody in the room who is a geologist and did geology at university will remember fellow students, usually physicists and mathematicians and chemists, telling you that geology was just about colouring in. And I think that we actually should embrace our love of colouring in, because actually what colouring in is, what it does for us, is it's a way of compartmentalizing information. That we're using, by colouring in, we are actually expressing a classification system, a taxonomy, to interpret what are essentially very complex natural systems. And that's why colouring in is associated with geology, because our science looks at some of the most complex natural systems. The Earth is a very complex place. So I think we should own colouring in. But of course, we aren't the only science that has used art as an important form of collecting data. For a long time, all the natural sciences relied on art and drawing in order to record complex spatial relationships, simply because that's too difficult to do in words or even in numbers. And this is a wonderful example. This is from Auburn's Book of American Birds. It's a very famous book. You'll find it in in ancient libraries around the world. There's very few copies of it left because the pictures are so beautiful. And this breaks my heart. People have torn the pages out and put them up on their walls. So geology's got a long history of drawing and illustration, actually so long that it predates our subject. So this is the first example I can find of a geological diagram. And this is from Conrad Gessner's book, De Rerum Fossilium, from 1565. 1565. So this is a woodcut. And I hope you can see, geologists in the audience will know that this is a fossil of an echinoid. And it's actually a really good picture. In fact, this would not look out of place in a modern textbook. Quite incredible for the time. And geological illustrations went on to be not only informative to show morphology and taxonomy, but also extremely aesthetic. And it's clear, this is a page out of Robert Hooke's book, Posthumous Works, published in 1705. And actually the artist is Richard Waller. So many geologists at the time, especially if you had money, would employ an artist to come and do all the illustrations for your book. And clearly the objective here is not just to show the form of these ammonites, but to show them in an aesthetic manner. Truly a beautiful book. But geologists went a lot further with their drawing than a lot of other sciences. So for example, geologists developed ways of illustrating the unseen. So rather than just drawing what was observed, they drew what was in the mind's eye. And this is actually the very first geological cross-section by James Hutton, which was a cross-section of Goats Fell in Arran. And so this is a synthesis of field data to try and interpret the subsurface and in turn, the geological history of Arran. And so here James Hutton is using art as a vehicle, both to understand, for interpretation, but also to communicate that result and that spatial and temporal relationships to an audience. And in our subject, that's particularly important because temporal relationships, we deal with deep time, with vast amounts of geological time, which makes our science very, very complex. And it was geologists who really utilized color in a unique way for the first time. And really this went along with developments in printing. The new development of printing technologies allowed the reproduction of these images. And that was using color as a means to guide interpretation of really subtle variations. And of course, in earth science, the difference in lithology between one unit and another can actually be very subtle. We talk about getting our eye in the field, about observing closely because of those really subtle variations. And color can be used as a means of communicating the differences between units. This is a great example. This is a map of Glen Tilt by John McCulloch, published in the Transaction of the Geological Society from 1815. And I suspect if I put up an aerial picture of Glen Tilt, the colors would look nothing like this, and it would be really difficult to see what was going on. And of course, that paved the way for the very first geological maps by William Smith. The use of color to describe something incredibly important for the UK's economy, the distribution of rock units over the landmass. And it's probably not too much to say that this dramatically influenced the economic development, not only of the UK, but of other countries around the world. and is still incredibly important today. Now, of course, other sciences, a lot of other sciences, stopped drawing. Art died in most of science with the development of the camera. Who wants to spend hours drawing a picture when you can quickly collect an image that you can use as evidence using a camera? But our science has continued drawing. So to this very day, drawing in the field remains a really important way of collecting complex spatial information. So every year I am out in the field with students, teaching students how to draw geology. And so that's why I suggest that our science is the most artful of all scientific disciplines, because we still use drawing all the time to collect data. And of course, the question is why do we do this? In fact, that's the question that's often asked to me by students. Why do I have to draw it? Can't I just take a photo? And this couple of pictures really demonstrates why we draw. So this is Ladram Bay in Devon, and or it might be Dorset, I'm not sure. Now, of course, a picture is worth 1,000 words, they say, but a photo is a picture. But photos suffer from rather restricted resolution. So you can only go down to an individual pixel. More importantly, photographs, especially the ones that I take, suffer from poor lighting. You know, if there's bright sunshine, you get deep shadows. If there's a bright sky, you end up with something like this, where it's really difficult to see any of those rocks. And any of you who are geologists and have been in the field, you know that you come back from field work with a camera full of photographs, and probably more than half of them you think, what is that? Why did I take that photograph? Whereas a field sketch enables you to show all of the details, whatever the lighting conditions are. And of course, photographs are also two-dimensional. Of course, now we have drones that you can fly around and build 3D models, but those have very restricted resolution. You know, an individual pixel can be an entire centimeter on the ground. Whereas when you're drawing a diagram in the field, you're actually there in front of the rocks. You can wander around them and draw them from all sorts of different angles. And then finally, and probably most importantly, photographs are just not memorable. It is too quick and easy to pull out your camera and take a photograph and then walk away without actually looking at what you're photographing. And that's the real importance of geological drawing. It makes us observe. When you draw, it encourages you to make observations of the details of the outcrop. So drawing becomes an aid to interpretation. It makes you pay attention to the very subtle differences in lithologies and structure in an outcrop. And it makes you identify the most important geological features in that outcrop. Now, of course, that also means it depends who is drawing. So, for example, a structural geologist will probably draw an outcrop very differently to a sedimentologist, because geology is a purposeful form of drawing. It depends on our objective, on how we draw an outcrop. So usually, when I teach students how to draw, they don't want to do it. And the reason they usually give is, well, I can't draw. And usually then they add, I can't draw because I'm not artistic. If they're really cheeky, they'll say, because I'm not artistic, I'm doing a science degree. And quite often the implication is that drawing is an innate talent one that you are born with. But is that necessarily true? Is drawing a talent that you gain from birth? Well, there isn't a baby in the world that can pick up a pencil and do a half-decent sketch. In fact, even when they get to 4 or 5 years old, we've all, had children or younger relatives who have given us a picture and, yeah, we put it on the wall, but it is rubbish. It takes learning. It takes practice in order to draw. And really, drawing just simply depends on hand-eye coordination. And any of these activities that require precision movement, they need muscle memory in order to learn. And that muscle memory can only be attained through practice. And it doesn't matter whether that's playing tennis, playing a musical instrument, or drawing. The only way you can improve your skills is through practice. And actually, muscle memory is, or motor learning, is actually a really interesting field. So human beings, we improve we reach our maximum expertise in any physical activity through repetition, through extended practice. And these curves show the initial phase. Oh, wrong button. The initial phase of motor learning is actually cognitive. It involves conscious thought and conscious learning of the rules of the activity. So we learn methods and techniques. And that probably gets you 50% of the way to your maximum ability in that activity. And with drawing, that maybe takes you 40 hours. 40 hours of practice, and you're already halfway as good as you're ever going to get. But then there's the long slog of motor learning. And that's the associative learning. And actually, there's a really easy way of doing that. If you want to improve your drawing, the really easy way of improving your drawing is just to practice all the time. And that's called doodling. And it doesn't even really matter what you draw. You can sit there and draw 100 squares of the same size, 100 triangles, 100 circles, and it requires 1% of brain power. You can do it while watching the TV, listening to a podcast, sitting on the train on the way home. And eventually your aim is that you can do that activity. Your fingers will draw those equal size squares or triangles or circles without you even looking at them. That's muscle memory. It also helps to use the right equipment when drawing. So there's no point doing a drawing, a field sketch, with a crayon on the back of a crisp packet. So, you need the proper equipment. Best thing to use is a pencil. This is my drawing kit. And actually, probably the most useful thing here for a geologist, it sounds ridiculous, the most useful thing is the pencil case. Because when I have walked 2 kilometers to get to an outcrop, I don't want to spend 10 minutes looking for my pencil. And I don't want to remember that I left it on the last outcrop. And a pencil case completely solves that problem. The rest of it is technique. And today, from now on, I'm going to be talking about the methods that you can use to try and improve your drawing. But be aware, this is not a magic pill. I cannot teach you, I cannot stand here and tell you what to do and you leave the room and magically you can draw. Because you need hundreds and hundreds of hours of drawing experience to learn that muscle memory. But we'll start with a few little tips. And the first one, and this is going to sound truly ridiculous, is about holding a pencil correctly. So I'm sure 90% of people in this room hold a pencil correctly, which is between the thumb and the forefinger. And and resting the hand gently on the page so that the tip of the pencil just makes a very fine mark. It sounds obvious to most of us, but as a lecturer, I can guarantee you that about 10% of people hold a pencil between the index finger and the forefinger. And actually, that gives you so much less control about where the tip of the pencil goes. There are a very small proportion of people, generally rugby players, that hold pencils like daggers and stab repeatedly at the page. And obviously that provides you with very, very little precision. So holding a pencil correctly is the first thing to do. If you've been doing it wrong, it's probably going to take you 20 hours to get used to holding it in the right way. You've been doing it for a long time. Another way of improving your accuracy is simply about where you put the page you're writing on, the piece of paper. So if you have it flat on a desk, for example, in front of you, you're looking ahead, then the piece of paper is at 90 degrees to the thing you're drawing. And as you look along the page, that drawing, it's in perspective. And the natural thing to do, the result of that, is that the scale changes up your picture. And just simply rotating the page round so it's nearly perpendicular to your line of sight, so it's parallel to what you're trying to draw, actually dramatically improves the quality of what you're trying to draw, probably by an extra 5%. And then there's memory. So us human beings, we've got excellent memories. So for example, I can remember, first memory, singing to a rabbit down a rabbit hole that my parents made me do when I was 5 years old. I can remember that, but I can't remember what the rabbit looked like. Because actually memory for images is really poor in human beings. It decays really quickly. And there's good biological reason for that we see a lot of things and we can't store all that information. So if you glance into a room and then look away, try and describe the objects in that room after one glance. You won't be able to. You won't be able to remember what color the teapot was in the corner of the room. And a really useful test about how good your visual memory is to try and draw something that's behind you. Just simply in the time it takes to turn around and start drawing again, you've lost enough of the visual image to make that really difficult. So your visual memory starts decaying after milliseconds. So that means it's much easier to draw something if your page and what you're drawing is in the same field of view and you can just flick your eyes between the two because you're minimizing the amount of time for that visual image to decay. And that too is associated with an improvement in your drawing skill. It's a very simple thing to do to improve your drawing. And the last biological related tip is down to biomechanics. So being in a comfortable position where you're free to move really helps you draw. Just imagine trying to draw if you're in a stressed position, you know, like you're drawing during Twister. That makes drawing really, really difficult. And you do see occasionally students halfway up a tree trying to draw the rocks in the distance. And it just makes, you know, why make life difficult for yourselves? Another big tip is using as few muscle groups as possible makes it quicker to learn to draw. So the more muscles you are using, the longer motor learning takes. So you see some people, when they draw, they're moving their entire arm, their elbow, their shoulder, whereas all you want to be moving is your wrist and your fingers, resting your hand on the page. The fewer muscles you use, the quicker that motor learning will occur. So all of that applies really to any art, but geological drawing isn't any art. Geological drawing is a very purposeful form of drawing because we're not drawing what we see or necessarily what's in our mind's eye, unless it's a schematic diagram. We are making an interpretation of what we see. Geological drawings are fundamentally interpretive. We are focusing on what are the most important geological features to us, which might be different if you're a sedimentologist or a planetary scientist, for example. So we emphasize the most important geological features. And I always think that there are three basic rules that in particular I use before I start drawing in the field. And the first rule is pretty obvious. Look first. Look before you draw. Before you even put a single line on the page, make an assessment of the outcrop. Because the first thing you want to ask yourself is this worth drawing? A typical mistake that people make is to try and draw too many things. You know, there's 8 hours in a day. The fewer drawings you do, the more time you can devote to each drawing, and the better they become. What is the reason for drawing this outcrop? What's the subject of this sketch? So here, very obviously, it would be this marvelous trough cross bedding and the sedimentology. And then that determines where you sit. Where's the best place to sit to draw this? The second rule, how much of it am I going to draw? So the subject might be right in the middle of my outcrop, but how much of the context do I need to put in my sketch in order for that subject to make sense? And once I've decided that, then I identify features on the outcrop which make it really easy for me to identify when to stop drawing. What's the margins to my picture? And then rule 3, how large am I going to draw it? And the classic mistake is to draw too small. Because of course, if you do a tiny little field sketch, then you have to be much more precise with your pencil movements. Whereas if it's half a page, then you're giving yourself a much better chance of doing an accurate field sketch. So usually, I don't do a sketch that's smaller than half a page of a notebook. And for landscapes, it's going to be a whole page. So then we get to the techniques that you apply once you start drawing. And probably the most useful is called blocking in. And this is something that artists do, where you draw a simplified version of what you have in front of you, the most important lines. So a good example is in trying to draw people. If you initially draw a person just as a series of ellipses to build the overall geometry of a human being, then you can add refined lines that actually make that outline much more accurate, before finally using that refined shape to add the details of that person. And we can use that same technique in drawing for geology. So a good example, here's Mount Everest. If I was to draw this, it's complex because it's got a very complex geometry, but it's also full of detail. And that detail becomes overwhelming. It's where do I start? And so the best place to start is by choosing the most important lines that define the geometry, which is all these horizons. And I just draw simple straight lines to make up that sketch. And then that defines the geometry for me. And once I've defined these regions, then I can start filling in the details using those straight lines as guides to where those details should sit. So it's really important right at the beginning to get these straight lines, this simplified version, this blocking in, to get those little points accurately on the page, like the tip, the summit of Mount Everest. And a great way of doing that is to be all scientific and imagine that in your field of view is a grid. And you say, well, that's the region I'm going to draw. That's my field of view. And there's a center line, both vertically and horizontally. And the summit of Mount Everest is close to the top of my field of view and slightly to the right. And I can do that with all of these little positions. on that diagram and literally put a dot on the page, having drawn on that grid system. And then just do dot to dot with my straight lines. And that produces a really accurate framework in which to draw. So one thing that's really important in getting on this grid, you can, and I've seen people do this, take a little piece of film with this photocopied onto the film and just put the film up in front of your head. But with practice, you can do it just in your mind's eye. But what's really important is the aspect ratio of that outline. And a great way of getting accurate aspect ratios and measurements is to sight measure. So you take your pencil, you hold your hand at arm's length, and you say, well, that object is about half a pencil high and about 1/4 of a pencil wide. And that immediately gives you the aspect ratio. And so you can get those details down as accurately as possible on the page. And then once you've got those guidelines in place by blocking in, then you can refine the details along those lines. And the way I do this is to have a constant narration in my head. And the narration goes like this. Well, here's my guideline along this slope, and I would say, well, actually, the real line drops below the guideline initially. Then it goes up again to about halfway along that line. It drops back down to the line, and then finally rises up in a curve until it touches that point. I have that narration just going on in my head for every single line I draw on the page. And it makes that image much, much more accurate. It also really helps you spot the geological features. Why does that bed suddenly jump? Oh, it must be a fault. So while we're talking about lines, the lines you should draw on your page should be clean, simple lines. So one movement of the hand, not scratchy lines like this. And you see a lot of people doing this, particularly those who can draw, who have done a lot of drawing in the past, because they tend to be somewhat more artistic, and they've learnt to put these artistic, imprecise lines. And the problem is, there's no way you can be accurate by doing that. And also, you're wasting an awful lot of effort. And it doesn't help your muscle memory to be moving backwards and forwards quite so quickly. So nice, clean lines. And you can use some variations in line thickness if you want to emphasize something like distance into the picture. So once you've blocked in, I like to think of a field sketch as adding progressive levels of detail. So you start with blocking in. So this is actually an outcrop in the middle tuff of Santorini. And so you can see I've blocked in this really simple outline of my outcrop. And then I've drawn the essential features. In this case, the subject of the sketch, which is this nice volcanic bomb with a bomb sag. And the essential features are the really obvious bedding planes. Then the next step is to add the extra detail, so the contextual features. And that's these more indistinct bedding traces on the outcrop. And you can see the way I've added them as dashed lines. And notice those lines, the dashes are not regular. So they're just discontinuous lines to show that uncertainty. And then I've chosen to add some of the larger clasts on as well as extra detail. And then the last stage is to add all the fancy stuff, or the ancillary detail. It's already a pretty good field sketch. But if I add the ancillary detail, so some jointing. Now, of course, if jointing is the reason you're drawing the outcrop, if that's what's fascinating to you, you know, you're interested in permeability or something, then your field sketch, that might be an essential detail. But things like features that show topography or vegetation, they're all ancillary detail. And they just add to the quality of that field sketch. So building up in levels of detail will vastly improve your drawings. Now, if you really want to get fancy, then you can start doing things like coloring in and shading. And shading is really useful for those outcrops, those exposures that have a three-dimensional character. So a cliff face, you don't really need to shade. But if there's lots of grooves and fractures, then it can be really useful. And what you really want to show is not the shadows that you can necessarily see on the outcrop. So if it's in bright sun, there will be directional shadows. It's the ambient occlusion shadows that you want to draw. And by ambient inclusion, that's the shadows that form in cracks and indents in an outcrop because they are furthest away from the light source, a dispersed light source. So essentially, where the outcrop is deepest, you shade. And I usually shade using a colored pencil rather than a pen. So some people, you know, they do lots of parallel lines, but then you're adding lines to the outcrop that don't really exist. And I find that if you do it in 2 stages, you do a first set of shadows in all the cracks, and then you just choose where the cracks are deepest to do the deepest shadows over the top, that it produces really optimal results. And then finally, if you want to, you can add color. And as we said, color is great because it allows us to segment the natural world, to show those really subtle differences and emphasize those subtle differences in lithology. And any of you who have done geology at university will probably remember being marked down for leaving streaks on the page. So a nice, light, homogeneous coverage of color is always best, but a few streaks are practically impossible to avoid. And then finally, in terms of basic geological sketches, geological drawings are diagrams. They are technical diagrams. They are not art. And that means that we need to have a technical labels and symbols on them. So we always have a scale and looking towards direction, of course. And then if you're doing a diagram, why not add lots of descriptive labels? In fact, my notebook is mainly filled with pictures with lots of labels on them rather than lots of words, lots of field notes. And then the final stage of your sketch is to add annotations. Why not interpret your sketch? So this is actually some folds in the Moyne schist in Glenfinnan, and it shows polyphase deformation, superimposed folds. And what I've done is I've added my interpretation of where the fold axial traces for those different generations of folds are. And so field sketches can be really useful for interpretation. So there are a few things that are more difficult to draw. So in particular, outcrops that have a three-dimensional topography to them. And this is one from Kinloch-Leven in Scotland. And these are mainly quartzites. You can see they have this step-like character, this outcrop. Now, in art, generally, when you draw a three-dimensional object, you construct that three-dimensional shape using vanishing points and guidelines. But actually, that's not necessary at all if you're drawing something you can see. You have to try and see your field of view as a two-dimensional picture. And then you can simply use the same technique of blocking in and identifying where in that field of view the features are to get them accurately on the page. And this involves turning off the monkey part of your brain that builds a three-dimensional picture of the world around you. You know, we see something that's three-dimensional and we immediately instinctively know about distance and angle. But actually, we need to think about it as a two-dimensional picture. And it makes it much easier to get it down on the page. And probably the most difficult thing to draw, the thing that gets a groan from an entire year of students, is to say, let's draw this landscape. And of course, the reason it's difficult is there is just so much detail there that it's almost overwhelming. And all you can do is divide and conquer. So during blocking in, you choose these different horizons. And this picture shows, this is a phreatic eruption crater, volcanic crater, sitting in front of Aldonyulengai in the East African Rift. Aldonyulengai being the world's only active carbonatite volcano. So here we've got several horizons. We've got the distant horizon that goes over Lengai and this cone. We've got the horizon that's on the top of that crater, and then we've got this near horizon. And so I block in those horizons, which breaks the picture up into individual regions with different scale. And then I can, inside those regions, work on each region separately and put in the essential geological features that I want to show, which here is the boundary between the different units. And then once I've done that, I can use those lines to position the detailed elements like the structures and the lithology. And those topographic elements like these little river valleys that show the shape of the landscape. And by breaking up a landscape like that, it makes it so much easier to draw. It takes a long time, but it makes even landscape drawing relatively easy. And that brings us on to your activity. So I've talked about methods and techniques, and I've stressed that it's no magic pill. Now we're going to find out if it really is or not. So this is a very famous locality in the UK. I'm sure many of you have visited it. This is Stair Hole next to Lulworth Cove. And so this is the Portland limestone, and this is the Purbeck limestones, the Purbeck beds, and actually the Jurassic Cretaceous boundary is in here, and these sets of folds the very famous Lulworth crumple. And this is actually a really difficult thing to draw because you can see it's in 3 dimensions. This stair hole is sticking out at us. And it's quite a challenging one. So what I suggest you do is block in. So add those simplified straight lines, then refine those straight lines and use that as a guide to add the detail. And I'm going to go back to the main picture. And if you are at home, try this as well. We won't be able to check. For you people in the room, I will be coming around and looking over your shoulder. And let's do this for, let's say, 10 minutes, which gives us about 5 minutes of questions. You're so much more quiet than most undergraduate students, apart from the undergraduate students. So having walked around the room, I've noticed some people felt really brave and decided just to try and draw the entire thing in one go. Other people were sitting and had yet to put a single line on the page. So you have to imagine it's a lovely spring day. It's the sound of seagulls, the gentle chatter of undergraduates talking about something inane behind you. It looks like mainly people who can draw came to this lecture. Okay, 2 more minutes. It's a bit like an exam, isn't it? 2 more minutes. There is so much concentration in this room. I can almost feel it. But unfortunately, I think we should move on. So having looked over shoulders, I can see lots of people using guidelines, blocking in at the beginning and using guidelines, which is really good. One little tip was actually folds are really easy to draw, most easy to draw if you draw the fold axial trace first. So you identify the line of the plane of symmetry, and then you draw the fold symmetrical around that plane. So, you know, I block in, refine the lines, start adding the essential detail. You can see me adding those fold axial traces. And then add all the ancillary detail. This took me much longer than you guys have had. And then I added some color and some annotation, and you know, I didn't add any seagulls for once, which is good. And notice I didn't try and draw individual blades of grass. That's another big student mistake, to spend more time drawing vegetation than you do drawing rocks. Anyway, so I hope you feel that in this lecture you've learned some techniques that maybe you can apply to improve your drawing, but really it's about practice. And you know, you can practice drawing anything and you'll get better at drawing in general. So for example, I'm really good at drawing rocks. I'm rubbish at drawing horses. They always look like dogs. But you should have a little hope that with practice, you should be able to draw at least as good as this person. So you can see these are pretty rubbish pictures of fossils. Amazingly, this is by Leonardo da Vinci. So you can probably draw as well as Leonardo da Vinci. And then I'm going to end the lecture with an absolutely shameless plug. So there is a book at this lecture. Thank you. Any questions? Oh, okay. Yeah.
Okay, thank you. Right, we're going to open up to questions. So I think I'm going to have some questions appearing on my screen as well. But for now, is there anybody in the room that wants to ask? Yep, got one down here. We'll just get a mic to you, sir, if you don't mind, just so everyone online can hear you.
You never mentioned deploying your rubber or eraser, but plainly you do, looking at your sketches. So when do you rub out the blocking in?
When I do something wrong. So you know, I like to make sure I have that. Most of the rubbing out goes on when I'm blocking in, when I've drawn the line in the wrong place. Once, if you blocked in accurately, then the rest of the sketch tends to fall into place. But everybody makes mistakes. Everybody uses rulers, uses rubbers. But you know, eventually, once you really get into drawing, once you've got that motor learning, you can actually draw without looking down at the page. You can just look at the object and draw it, and your hand will know what to do. Eventually, you know, you might have the odd glance down to make sure you haven't made a horrible mess, but eventually your hand knows what to do, where to go.
Okay, I'm going to read one out from online, from Rich Arthur, who says, Matt, do you like the modern trend to make geological maps garish colours that follow none of the classic schemes? Or like me, do you think pastel colours and blue for limestone, red for igneous, etc. are more useful?
Well, yeah, so I get to mark maps. So some of our students are here, and they're going to be doing this field trip soon, from the Scotland mapping field trip. And there, yes, we get really garish, even day glow colours, and we don't mark them down for it. But John Cosgrove, who comes with me, who's a structural geologist, hates purple with a vengeance. So John will mark you down for using purple or any form of mauve. So I'm not a purist, and I don't think it really matters.
As long as they're different, and as long as there's a key or legend.
As long as you can tell the difference, as long as there is a legend, a key to units. It's good. It's a good idea if your map doesn't actually make you feel physically sick.
Fantastic. We've got one just down here in the room.
If I may cheekily get two questions in. Thank you for your talk as well. I've really enjoyed the drawing too. Do you have a favourite example of a time when drawing something brought something to your attention that you would have missed if it was just a photo? And also, do you draw for pleasure? And if so, what do you draw?
So yes, I do. I have a couple of examples of things that I drew that I just went, oh wow, that really makes sense. So one was in Santorini, where I'm drawing the units, and it was only then that I noticed there were these little faults. And then really concentrating on the little faults, I noticed that the faults, the displacement on the faults decreased upwards and then suddenly stopped at the overlying unit. And the entire thing was in one eruptive sequence. And so that was evidence that that fault was moving during the eruption, and its displacement was decreasing until finally it stopped. And that was, and there were normal faults, so that related to, you know, during an eruption of a caldera, the magma chamber is emptying and the caldera is subsiding into the magma chamber. Fault movement during an eruption. So that was really cool. I really like that. And the second story is, and this is actually quite sad. I once dreamt about an outcrop and then woke up in the middle of the night and just had to draw it while the memory was still there. A fantasy dream outcrop. It was an ignimbrite.
And the second part of the question?
With rheomorphic folds. They were really good rheomorphic. What was the second part of the question? Sorry. I do draw for pleasure, yes, I do. Usually I actually paint. I use pastels. I really like pastels, fingers on the page.
Okay, we've got a question online from Tony McCready in Glasgow, who says, do you recommend inking in field sketches?
Oh, yes, absolutely. And for the main reason that, well, number one, it's fun. I love it. But number two, I've got notebooks that I did when I was a PhD student, which was a long, long time ago, and they look as if they were done yesterday. And the reason is I inked them in. They would be unreadable today. They would be completely unreadable. So pencil marks on a page, they eventually will rub off and smear onto the opposite page. So it's best to ink them in.
Okay, we don't have any hands in the room yet, so I'm going to go back to online because there's quite a few here. Diana asks, how detailed should an interpretation on a geological field sketch be?
That's a good question. Well, it depends what's there, really. So as much as you can fit on the diagram, that's my general when it comes to interpretation, interpret as much as you can in the field. It's much easier in the field while you're sat in front of those rocks to make that interpretation. Now, obviously, you don't want the diagram to become so cluttered with interpretive lines and with annotations, but it's so much easier when you're in the field in front of the rocks to do that direct interpretation.
Okay, we've got one down here. If we can get a microphone to the front, thank you. And whilst we're getting the mic, Julie says, thank you from Frankfurt. We really enjoyed this. So you've got people everywhere.
For your interpretation afterwards of what you've done, do you find it worthwhile sort of repeating drawings of the same area with different lighting conditions?
Well, the idea being, you know, the eyes of human beings is really good at seeing through shadow, at seeing, you know, you can look into a deep shadow, and if you stare at it long enough, you can see what's going on in there. So I do repeat diagrams all the time, but that's because I'm a lecturer and I go back to the same place year after year, and I have to draw it again on the whiteboard so the students can see it. But, you know, there is a general rule of thumb that you shouldn't revisit the same locality. You know, you shouldn't keep going back to the same place because, you know, you should have made all those observations the first time. If you have to keep going back, there's something wrong.
Okay, I'm very conscious of the time, so I'm sorry that we won't get to everybody's questions online, but I'm going to finish with one from Harry. It's a bit of a big one. He says, I'm an A-level geology student. What's your biggest bit of advice for a career in geology?
Ooh. Wow, that is a big one. Biggest bit of advice for an A-level geologist. The best geologist is the one who has seen the most rocks. So that's H.H. Reed, I believe, who said that. And it's absolutely true. So get yourself out into the field, collect rock specimens, learn about those rock specimens. And that will put you miles ahead of everyone else when eventually you get to university. It will also really impress the person who's doing your interview. Because one of the things we like to do at university when we interview you is there will be this mean old interviewer that will pull out a rock and say, what do you think of this? And if you can actually say more than 2 words about it, we're usually quite impressed.
Okay, Harry, I hope that helped answer your question. And there are obviously an infinite number of answers to that question. So keep asking it every time you have the opportunity. So thank you very much to everyone for coming along tonight. We've had over 80 people online, so I'm really sorry. There's so many questions and comments here from all over the world, South Africa as well. People are super happy. So I'm sorry we didn't get to everyone, but in the interest of time and to give everyone their evening back, so we are going to draw it to a close here. So thank you very much to everyone in the room. Thank you very much to everybody online. And if we can all just thank Matt again once more for this evening's talk.
Thank you. So I don't know what we do with your sketches. You can take them home. You can leave them here. Natasha no doubt has a notice board to put them on.
We could certainly try. Thank you. You've got a lot of comments here. Kevin's put them on the room for you, on the screen for you. You might scroll down so you can see some of these extra ones. I can go to the A-level students. Canada, South Africa, Germany.
Yeah, nice.
Yeah.
Yeah, good. It was really good. It was really well paced. I'll let you
Stuff I can see sickness. So that sketch or fingers came, that would have taken you several hours. And the only way to get that view is sitting in the boat.
Yeah.